In this problem, we suppose that an airline uses a seat width of 16.1 inches. We assume that men have hip breadths that are normally distributed with a mean of 14.6 inches and a standard deviation of 1.1 inch. It's important to notice that we're working with a normal distribution that has a population mean of 14.6 and a population standard deviation of 1.1 inches. The question is, if a plane is filled with 126 randomly selected men, find the probability that these men have a hip breadth, the mean hip breadth, greater than 16.1. We're going to round to 4 decimal places. So what's key about this question is to recognize that our sample size n is 126, and we're working with finding the probability of a mean, not a single score. When we're working with means, and we want to find probabilities associated with them, we need to know the standard deviation for the distribution of sample means. This is the standard deviation for the initial normal distribution, but we're going to need to compute the standard deviation, which is also called the standard error of the mean. That's sigma x bar, which is found by your standard deviation for the population over the square root of your sample size of 126. So we can do that in our calculators. I'll use the one on the computer, and you'll see I've already computed the standard deviation for sample means, the standard error of the mean, as 1.1 divided by the square root of 126. And if you're using the calculator on our computer, I'll show you how to do that. 1.1 divided by, and to get the square root of 126, we have to first enter 126 and then find the square root of it. So what it shows us first is the square root of 126, and then we have to hit equals to get the 1.1 divided by that square root. So we'll use 3 decimal places and round this to 0.098, and we can use that in StatCrunch. So to find the normal distribution, we would go to Stat, Calculators, and Normal. Again, that's Stat, then Calculators, then Normal, and that will bring up this screen. Now, it's not a standard normal distribution. It is a distribution of sample means. So according to our central limit theorem, the mean stays the same as the population mean, but our standard deviation becomes the standard error of the mean. That's that 0.098 number that I computed using the calculator. 16.1, it is now a sample mean, and we notice that we want the area to the right greater than, so we have to change this. We click. It is a very, very, very small probability that you would get something as large as 16.1 for a group of 126 men that now has a standard deviation of 0.098. It's more than 1, 2, 3, more than 4 standard deviations away. It is several standard deviations away. We could compute that with our z-score, but for now we can see that the probability is essentially 0 because it is so far away. And I hope that helps with the difference between finding the probability associated with a single score and finding the probability associated with a mean. We have to change the standard deviation so that is taking into account the sample size.